Welcome back. So, what are the variables that go into determining the type of stream channel that is created by a stream or dictated by the geology to contain a stream? So, channel development and the landforms that are created are influenced by the gradient, so how steep an area it is. Excuse me. The discharge, the amount of water flowing through the channel. More water versus less water might give us different channels, different landforms, and then something called load. Or the bed load, suspended load, and dissolved sediment carried by a stream. So bed load is large, heavier pieces of sediment moved along the channel bed, the bottom, so kind of bigger pieces, pebbles, rocks, those sorts of things. Suspended load, small sediment suspended by flowing water. So if you've ever driven over a large river and it looks kind of brown and muddy, that's the suspended load. That's all the dirt, silt, sediment in the water itself. It's suspended in there. Once that water slows down, that sediment deposits out. And then you have dissolved sediment, dissolved load, and this is the, talking submicroscopic atomic, ions, molecules in solution from things like chemical weathering, breaking things down. So we're talking about the small molecules that are dissolved into the water itself. So all of these, these three factors kind of determine, well, what type of stream channel might you have. And let me move me out of the way. Before we do, let me give you another part of the super secret code. It is the number 4. You got me? The number 4. One more time, the number 4. So, straight stream channels, again, typically higher gradients, lower amounts of discharge and lower amounts of load, so the water is going to be more clear, less material. The discharge is low up in the mountains where the rivers are getting started, so less discharge, less water typically, but again, higher gradient. Meandering streams, they're low gradient, higher discharge, so not steep, a lot of water, and it has a high amount of load, most of that suspended load. So material in the rivers themselves, that, again, gives it that brown, murky look to some large rivers. I think of the Mississippi River anytime I drive over it. And then braided stream channels, also low gradient. Discharge is variable. It depends. It could be low, it could be high. Just depends, because again, a lot of this is right at the base of a mountain, so material coming off of melted glaciers. So there's some other factors. So the amount of water discharge can be variable, and the load is also high, but a lot of it bed load, a lot of it bigger pieces. So it's these factors that kind of go in to determine, well, what kind of stream channel will we have. When we're looking at a stream itself, let me move me back. Streams have different stages. This is what characterizes a different stage indicates a stream as either being youthful and young, mature, middle-aged, or old. So a youthful stream stage are typically what we find a younger stream, steep gradients, generally flow in a V-shaped valley, high velocity, little to no floodplain, rapids, and waterfalls. So, straight stream channels. Those are typically youthful streams. Streams starting up in mountains in the high gradients. Typically youthful streams. They're rather young. Mature, or kind of middle-aged streams, moderate gradient and velocity, carving out a valley floor, periodic flooding, small floodplain. So we're starting to get into now braided and meandering a little bit, and then, or I'd probably say more braided. And then as we get into old streams, gradient and velocity are very low, deposit as much material as it erodes away. Meanders greatly, very wide stream channels, well-developed floodplain marked with oxbow lakes. Excuse me, my goodness. So that's more typical of a meandering stream channel. In all of these characteristics and all of these things and all of these stages, there's a lot of overlap. There's no one perfect thing. Oh, this stream channel fits in this category. There's a lot of overlap, a lot of factors you have to look into. I'm just saying things in general. So youthful streams, mature streams, old age streams. All right, so a good indication. Looking at a youthful, more V-shaped valleys, mature, developed floodplain. youthful, most likely straight stream channels. Old age meanders a lot larger stream channel. But if you look at mature, you could still have straight stream channels for the most part. So again, there's just some overlap. You just got to kind of look at what's going on. So we're talking about all this water on the surface, mostly talking about streams, but again, lakes and swamps and stuff are part of this. Where does all this stream water come from? Where does it all come from? How does it get into these certain areas? Well, then that leads into a conversation on drainage basins. Drainage basin. A drainage basin is a collection area of precipitation, rain, snow, etc. So it's an area that when water falls onto it, rain, snow, hail, whatever it may be, it kind of collects it into a certain area. It's the total area from which water flows into a particular stream. So for instance, as looking at larger drainage basins, so everything in the purple, if any type of precipitation falls in this area, it will eventually flow into the Pacific Ocean. Any material falling in the green here will eventually flow into the Atlantic Ocean. The red here, or the pinkish, orange, I don't know what color that is, any water that would flow here would flow into the Gulf of Mexico, which technically is part of the Atlantic Ocean. Any of these yellow areas, these are basins, and water doesn't go anywhere. It just stays there and evaporates. It doesn't really flow anywhere. Kind of interesting to note. Blue goes into the Arctic Ocean. Now, what separates all these larger drainage basins, and we can actually divide each of these up, but what separates drainage basins are something called divides. A divide is a topographic high kind of separation line that separates adjacent drainage basins. Typically, mountain ranges, but other high topographic points that will say if water falls on one side of the mountains, it's going to go one way. If water falls on another side of this mountain, it's going to go the other way into a different stream or into a different body of water. In the U.S., we can take some of those larger drainage basins and kind of direct it into more specific rivers for the most part. So for instance, here in Arizona, we are in the Colorado River Basin. The Colorado River starts in Colorado, flows through Colorado, Utah, Arizona, border of Nevada, and California, and it actually doesn't even flow into Mexico anymore. We use too much of the water, so it doesn't even flow into the ocean anymore. It just stops. It's pretty sad. Again, Arizona water, not a good mix, not a good place to live. Move. All right. In any case, so any precipitation that falls, as an example, in this yellow area will eventually drain into the Colorado River. It's the Colorado River Basin. So any precipitation that falls into Arizona will eventually flow into the Colorado River. Anywhere, any point. Look how large the Mississippi/Missouri River drainage basin is. This green area. So much area, it catches so much rain. That's why the Mississippi River is so large, because it has such a big drainage basin. All of that water gets funneled into eventually the Mississippi River. Such a big drainage basin, such a big river. So yeah, between all of these different colors, those are all divides. For instance, the Appalachian Mountains running right here. On one side, it flows into the Mississippi drainage basin. On one side, it flows into the South Atlantic Gulf drainage basin. But one of the biggest divides is the Great Divide, also sometimes known as the Continental Divide, that flows along or runs along the top of the Rocky Mountains. If precipitation falls on one side of the Rocky Mountains, it makes its way to the Pacific. If precipitation falls on the other side of the Rocky Mountains, it makes its way to the Atlantic Ocean. So again, here's that map of Arizona and all of our surface streams, including rivers, creeks, and washes. Washes are intermittently filled channels of water. You might be familiar with that, especially living here in the Phoenix area. Often they're dry, but if it rains, we can get water flowing in them. Those are typically washes. But you can see CR for creeks, R for rivers. Brooks are too small to really put on this type of map. So again, Arizona is pretty diverse in its surface water, believe it or not. Again, the Colorado River making up the western boundary of Arizona. And remember, any precipitation that falls into Arizona will eventually filter into of the Colorado River. For example, if, let's see here, let me draw on something. So if rain fell here, it would go into the Gila River. The Gila River would drain into, well, it connects to the Salt River, but from here it connects and continues into the Gila River and then flows eventually into the Colorado River. All right, so if something falls here, it might fall into the, drain into the Big Chino Wash, which connects to the Verde River, which connects to the Salt River, which again connects to the Gila River, and then onto the Colorado River. So that's, yeah, that's how that works. All right, let's go on to the next slide here. Let me get rid of something here. So just want to highlight a few of Arizona's longest rivers, types of stream. So let me just go through those. So the rank from 1 to 10. The ones in parentheses indicate the longest rivers as it pertains to the U.S. So the Colorado River, which starts in Colorado into Utah, Arizona, etc. It's the longest river in Arizona. It's also the 5th longest in the U.S., over 1,400 miles long. The Gila River comes in second, actually starts in New Mexico and makes its way again through Arizona. 2nd in the state, 27th in the country. Then we have the Little Colorado River, which eventually flows into the Colorado River towards the Grand Canyon. The Salt River starts up in the White Mountains, cutting through the Phoenix area, connecting to the Gila River. Santa Cruz River down through the Tucson area. The Verde River kind of through Prescott and the Verde Valley as it flows into the Salt, which flows into the Gila, which flows into Colorado. The Puerco River, here it is, flows into the Little Colorado, which flows into the Colorado. What's that one? The Virgin River flows into the Colorado. The San Francisco River flows into the Gila River, which flows into the Colorado. The San Pedro, also down near Tucson way, flows into the Gila, which eventually flows into Colorado. It all flows into the Colorado because we are in the Colorado River Basin. All right, we're going to go ahead and pause here. When we come back, we'll talk about different types of landforms that may be a byproduct of flowing streams. I'll see you back here in just a minute.